Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering. And students, this is the lecture for Civil 6th semester class, and the subject is Professional Practice. So, students, in the earlier lectures also, we were discussing the various analysis of rates for different items, and we have discussed the analysis of rates for earthwork in excavation, then earthwork in banking, then cement mortars, after that cement concrete works, and now students, we will discuss the analysis of rates for reinforced cement concrete. So basically, what do you understand by reinforced cement concrete? Cement concrete is the mixture of various ingredients of concrete, that is fine aggregate, coarse aggregate, cement, and they are mixed up with the water and the concrete is produced. Now, reinforcement reinforced means that the cement concrete is including the reinforcements also. So, if we are talking about the reinforced cement concrete, the concrete which is including the reinforcement part, that is known as the cement reinforced cement concrete, which is having the various reinforcements induced, and around that reinforcement or within that reinforcement the concrete is mixed up or placed, that is the reinforced cement concrete. Basically, the reinforcement along with the mixture of the ingredients of the concrete gives us the reinforced cement concrete. Now, students, talking about the analysis of this reinforced cement concrete item, so basically the reinforced cement concrete involves the analysis in various different parts comprising of the analysis of rates for the materials, which is including your steel or the reinforcement bars, binding wires, etc., and along with the various ingredients as we have discussed in the cement concrete works. So the analysis of rates for reinforcement cement concrete, it involves the analysis in four major portions, which includes your labor, your material, then your reinforcement part, and then your centering and shuttering part, and additional to that the machinery part. So these components make the analysis of rates for the reinforced cement concrete works. Students, you can see the question which you may get in examination. So we will discuss the analysis by this question: providing and laying in position reinforced cement concrete 1:1.5 ratio 3 for beam lintel with 2% steel. So basically, students, nowadays when we look into the DAR, that is the detailed analysis of rates, which I have already shared with you in the WhatsApp groups. So you will find that the analysis, it is not including your centering, stuttering, and reinforcement part. When you go through the analysis of rates 2014, and after 2001, after the year 2001, when we pick up any analysis of rates which is issued by the CPWD, Central Public Work Department, it will not include the cost of the centering, shuttering, and reinforcement. The analysis of rate for centering, shuttering, and reinforcement is given separately. The item is not clubbed, right? But when we look into the DAR 2001 or before the year 2001, the analysis of rates which we obtain through that government organizations, it includes the clubbed item, that is which I have mentioned in the question: providing and laying in position reinforced cement concrete 1:1.5:3 for beam lintel with 2% steel. So in this particular question, you have been given the ratio proportioning of the cement concrete, which is 1:1.5:3. Then you have been given the quantity of the steel which is to be placed in the lintel, that is 2% steel. So we have to prepare the analysis, considering the analysis which is including the cost of centering, shuttering and reinforcement. So basically we are following the DAR which is for the year 2001 or before 2001, right? So basically students, when you are getting the question in the examinations and you have been given the quantity of the steel to be used is 2% or any percentage, and you have to include the cost of the centering, shuttering and reinforcement, then you have to follow the same pattern as discussed in this lecture. So students, if you are getting the normal question about the reinforced cement concrete 1:1.5:3, and if it is not including your centering stuttering portion or it is not including your steel portion, then neglect that particular components from this particular analysis and you will be able to attempt the same question. So in detail we are going to discuss now the analysis of rates including the 2% steel and including the cost of the centering, shuttering and reinforcement. So calculation, as we have discussed in the earlier analysis also, the calculation of the dry volume of the concrete or of the particular item for which we are preparing the analysis is very essential before going for the analysis. So students, dry volume calculation is as follows: volume of wet concrete, that is 1 cubic meter, and to achieve the dry volume of concrete the wet volume may be increased by 56%. So students, earlier also when we have discussed the item of the cement concrete works, we have increased the wet volume by 56% only to to achieve the dry volume. So for the reinforced cement concrete works also, we will increase the wet volume of the concrete by 56% to get the dry volume. So therefore the dry volume of the concrete will be 1.56 cubic meter. So this is the calculation of the dry volume of concrete of reinforced cement concrete, that is 1.56 cubic meter. So students, now calculation of the quantity. So as we have done the previous analysis, the same steps will be followed for the calculation of the material, that is a sum of proportion, that is 1 plus 1.5 plus 3 equal to 5.5. So quantity of cement and quantity of sand and that stone aggregate will be calculated in the same manner. I'll explain you. Quantity of the cement equal to dry volume divided by the sum of proportions into proportions of the material. So 1.56 divided by 5.5 into 1, so it will be 0.283. Now we are converting this into the tons, so it will be 0.40 ton. So students, the same procedure of the calculation of the quantities will be followed as I have explained you in the previous analysis of rates, and the quantities will be calculated. So quantity of sand, that will be again the dry volume divided by the sum of proportion multiplied by the proportion of the coarse sand, that will be 0.42 cubic meter, and the quantity of stone aggregate, as we are using 1:1.5:3, that means the large size aggregates, they are not considered because it is not the PPC, it is not the PCC, plain cement concrete. Basically, it is the RCC, reinforced cement concrete, and it is not used for the PCC works. That means it is not the lean concrete. It is the reinforced cement concrete or the cement concrete, because the ratio is 1:1.5:3. So 20 down aggregates or the nominal sized aggregates, they are used, and we have calculated the quantity as dry volume divided by the sum of proportion multiplied by the proportion of the stone aggregate. That means 1.56 divided by 5.5 multiplied by 3, and it will be equal to 0.84 cubic meter. Now students, further it is the analysis, how the analysis have been prepared. So students, material, which is the cement, coarse sand and stone aggregate, steel and binding wire. Now students, 2% steel has been utilized. Cement we have calculated, coarse aggregate we have calculated 0.42, stone aggregate we have calculated 0.84. Now, how this quantity of steel has been taken into consideration? For this quantity of steel, unit is quintal, and uh, this value has been obtained as per the data given in the question, that is the quantity of steel at the rate of 2% per cubic meter. So considering this 2% per cubic meter, 2 divided by 100 multiplied by 1, it will be equal to 0.02 cubic meter, right? So as 1 cubic meter, it is equal to 78.5 quintals. Now students, I am repeating this again, how this quantity of steel, that is 1.57 quintal, has been calculated. Students, you have to take the calculation from the statement, that is quantity of the steel is at the rate of 2% per cubic meter. So 2% per cubic meter will be 2 divided by 100 multiplied by 1. It is equal to 0.02 cubic meter. And as 1 cubic meter includes 78.5 quintals, therefore 0.02 cubic meter multiplied by 78.5, it will give us 1.57 quintals. So 1.57 quintals, it can be converted into the tons also, that is 0.157 ton, right? So this is 1.57 quintals because the unit is quintal. So steel calculation is like this, and the binding wire is taken as at the rate of 1 kg per quintal. So binding wire can be taken at the rate of 1 kg per quintal, and it will be equal to 1.57 kgs. So students, this is the calculation of the material: cement, coarse aggregate, stone aggregate, steel and binding wire. Now carriage of the material, again cement, sand, stone aggregate and steel. Steel, the carriage will be as same, the rate of the carriage will be as same as that of the above given, that is cement. Then labor part will be divided into the different components, which is for the concreting, for reinforcement and for centering and shuttering, and for binding of the steel. So mason, beldar and bishti for the concreting, then for reinforcement blacksmith, beldar, and for centering and shuttering carpenter and beldar. So students, we are going for the analysis for the reinforced cement concrete. That means the cement concrete part will be additional, the reinforcement part will be separate, and the centering and shuttering labor will be separate. So separate labors have been considered, right? So for this calculation of the blacksmith and the beldar, the unit, obviously it will be the day only. Blacksmith is 1.57. So how this 1.57 blacksmith has been calculated? You can see this: for 1 quintal of the steel, the blacksmith required will be 1. What is the factor over here? For 1 quintal of the steel, the blacksmith required per day will be 1. And as we are having the steel of 1.57 quintal, so blacksmith required will be 1.57. And same quantity beldar will be required. Students, this calculation of the labor quantity for the reinforcement is related with the steel quantity, right? So for 1 quintal of the steel, for binding of the 1 quintal of the steel, the number of blacksmith required per day is 1. So for 1.57, the quantity will be 1.57. And for the carpenter, it is 1, and beldar it is 1 for centering and shuttering works. And after that, students, machinery part, if we include the machinery part, so it will be having the centering and shuttering the material which is required for the centering and shuttering. Now it is not the labor component, it is the material which is required for the centering and shuttering. And for centering and shuttering works, higher charges, that is 5% of the cost of the material. 5% of the cost of the material. So you can see this cost of the material. It is 11484.2. This cost of the material. I have added the cost of the material. That is 11484.2, and 5% of this figure, it is 574.2. Then higher charges, this is for including the removing also. Then nails, which is required for the centering and shuttering, so it is 10% of the higher charges. So 10% of the higher charges will be 57.42. So after that machinery, it will be higher charges of the concrete mixtures, it will be 50, which will be 56. Then vibrator 22.75, and sundries lump sum amount has been taken as 25.45. So this all will be added up, and water charges at the rate of 1% will be added. Then contractor profit and overhead charges of the rate of 15% will be added, and then the total amount per cubic meter of the reinforced cement concrete work, including the reinforcement, centering, and shuttering, will be computed. So this is the analysis of rates for the reinforced cement concrete work. Thank you.